On top of the sine and cosine trigonometric functions, there are other trigonometric functions that come from the sine and cosine. In this section, we're going to explore those. So here's what we know so far. For a point x, y on a circle with radius r at an angle theta in standard position, where x squared plus y squared equals r squared, in addition to the fact that the sine of theta is equal to y over r and the cosine of theta is equal to x over r, we can now define the functions tangent, cosecant, secant, and cotangent as follows. Let's begin with the tangent of an angle. The tangent of an angle is abbreviated TAN and is equal to the ratio of the sine of theta over the cosine of theta. The sine of theta is y over r, the cosine of theta is x over r. The r's in the denominator cancel out, and we're left with the tangent of theta equaling y over x, where x cannot equal 0. Next is the cosecant of an angle. Cosecant is abbreviated CSC. The cosecant of an angle is equal to 1 over the sine of the angle. This is the reciprocal of the sine function. Since the sine of theta is defined as y over r, then the cosecant is defined as r over y, where y cannot equal 0. Now let's move to the secant of a function. Secant is abbreviated SEC and is equal to 1 over the cosine of theta. This is the reciprocal function. So we know that the cosine of theta is equal to x over r, and therefore the secant of that same angle is r over x, where x cannot equal 0. And finally, the cotangent of theta. The cotangent of theta is equal to 1 over the tangent of theta, or the reciprocal of the tangent function. That leaves us with the cosine of theta over the sine of theta, or x over r over y over r. Like we saw with the tangent function, the r's cancel, and I'm left with x over y, where y does not equal 0. Notice that the tangent of theta equaled y over x, and now we say that the cotangent of theta is its reciprocal, or x over y. We can summarize the trigonometric function values of the common angles in quadrant 1. We've already done that for the cosine and the sine of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, and of course their equivalent radian measures. But now we can complete this table by looking at the tangent, secant, cosecant, and cotangent. Now, we just learned those relationships between those function values and the sine and cosine, so they're being provided for you on this chart. But your ultimate goal would be to be able to memorize or remember those relationships. So let's begin with the tangent. The tangent of an angle is equal to its sine over its cosine. So for 0 degrees, the sine is 0 and the cosine is 1. So 0 over 1 is equal to 0. For 30 degrees, or pi over 6, the sine is 1/2. So 1/2 divided by the cosine, which is the square root of 3 over 2. And if I, instead of dividing by the square root of 3 over 2, I multiply by the reciprocal, the 2's will cancel out, and I'm left with 1 over the square root of 3. If there's a radical in the denominator, you should rationalize it, and you can do that by multiplying it by itself in this case. And if you do that in the denominator, you have to do that in the numerator. And now multiplying straight across, I get square root of 3 over 3. So the tangent of a pi over 6 radian measure, or a 30-degree angle, is equal to square root of 3 over 3. For 45 degrees, or pi over 4, the sine and the cosine are the same. So when I divide those same values, I get 1. For 60 degrees, or pi over 3, the sine is the square root of 3 over 2, and I'm going to divide that by the cosine, which is 1/2. Instead of dividing by 1/2, I will multiply by the reciprocal of 2 over 1. The 2's cancel out, and I'm left with the square root of 3. So the tangent of a 60-degree angle, or pi over 3 radians, is equal to the square root of 3. For 90 degrees, or pi over 2, the sine is 1 and the cosine is 0. So here we have a problem because 1 divided by 0 is not possible. So we say that the tangent of 90 degrees, or pi over 2 radians, is undefined. Undefined. All right, let's move on to the secant. The secant is defined as the reciprocal of the cosine function. So the cosine function in this case is 1 for 0 degrees, or 0. So 1 over 1 is simply 1. For 30 degrees, or pi over 6, I'm going to have 1 over that cosine. So 1 over the square root of 3 over 2, which is 2 over the square root of 3. I'm going to rationalize the denominator like you saw me do before, and I get 2 times the square root of 3 over 3 for the secant of a 30-degree angle, or pi over 6 radians. For the secant of 45 degrees, it's the reciprocal of the cosine function. So I'm going to take that square root of 2 over 2 value, and I'm going to reverse the numerator and the denominator, and I'm going to rationalize the denominator. So that leaves me with 2 times the square root of 2 all over 2. And the 2's cancel out, and so I'm left with the secant of a 45-degree angle, or pi over 4 radians, being equal to the square root of 2. The secant of 60 degrees, or pi over 3, is again the reciprocal of the cosine function. So the reciprocal of 1 over 2 is 2 over 1, which I will call 2. And finally, the secant for 90 degrees, or pi over 2, is 1 over 0. And like we saw with the tangent, this one is going to be undefined. All right, for cosecant. Cosecant is the reciprocal of the sine function. So we're going to have 1 over, in this case, that sine function was 0, and 1 over 0 we have seen is undefined. For pi over 6, or 30 degrees, we're going to have 1 over that sine function. So 1 divided by 1/2 is simply 2. For 45 degrees, it's going to be the reciprocal of the sine function, which, because the sine and cosine are the same, then the same thing that we got for secant, we're going to see for cosecant. So this answer is going to also be the square root of 2. For pi over 3, or 60 degrees, the reciprocal of the sine function is going to be 2 over the square root of 3. I think we've seen that before, but I'm going to go ahead and rationalize that denominator, and I get 2 times the square root of 3 over 3. It should not surprise you that the secant of a 30-degree angle and the cosecant of a 60-degree angle are the same. And that's because of that relationship between 30-degree angle and 60-degree angles. All right, and let's finish up the cosecant. We're going to have 1 over the sine function, which is 1. And so the cosecant of pi over 2, or 90 degrees, is 1. For the cotangent, we simply need to take the reciprocal of the tangent function. So for tangent, we saw that for 0 degrees, it was 0 over 1. So we're going to just go ahead and reverse the numerator and the denominator, and we find that that is undefined. So I'm looking up here at this tangent function, and I just reversed it for the cotangent. For the 30-degree angle, or the pi over 6, I'm going to take this tangent value, and actually I think that answer, the square root of 3 over 3, was when I rationalized the denominator. Before I rationalized the denominator, I had 1 over the square root of 3. So if I reverse the numerator and the denominator, I get just the square root of 3. For pi over 4 or 45 degrees, the reciprocal of 1 is 1. For 60 degrees or pi over 3, the reciprocal of square root of 3 is going to be 1 over square root of 3. And you've seen me rationalize that denominator a few times now, so you get square root of 3 over 3. And then finally, the reciprocal of the tangent of 90 degrees or pi over 2. The tangent was 1 over 0, so the cotangent is going to be 0 over 1, which is equal to 0.